Welcome to our channel where we explore the amazing world of science. In today's video, we're going to take a closer look at the world of magnetics and explore 5 amazing experiments that will leave you in awe. Magnets have always been fascinating to us, and we've all played around with them at some point in our lives. But did you know that there are so many incredible experiments you can do with magnets? We're talking about mind-boggling, heart-racing experiments that will leave you amazed and wanting more. From levitation to creating your own magnetic slime, the possibilities are endless when it comes to magnetics. We'll be taking a closer look at 5 amazing experiments with magnetics that will blow your mind and keep you entertained for hours on end. So grab your lab coat or just an old t-shirt, strap on those safety goggles, and let's dive into the world of magnetism. What is magnetism? Magnetism is a force that can either attract or repel objects. It is caused by the movement of electrons within atoms. When the electrons spin in the same direction, they create a magnetic field. This field can either attract or repel other objects that contain magnets. Magnetism is used in many devices, including electric motors, generators, magnetic resonance imaging MRI machines, computers, credit cards, speakers. How do magnets work? Electricity and magnetism are 2 closely related physical phenomena. Magnets are objects that produce magnetic fields, which can then interact with other magnetic objects. The strength of the magnetic field depends on the material of the magnet and how it is shaped. For example, a bar magnet has a stronger magnetic field than a horseshoe magnet. Magnets can either attract or repel each other. They also interact with electric currents to create forces that can be used to power motors or generate electricity. Number 1. Magnet and iron filings experiment. In this experiment, we will use a magnet and iron filings to observe the magnetic field created by the magnet. Materials needed: magnet iron filings tray or plate, white paper procedure. Place the white paper on the tray or plate. Sprinkle a small amount of iron filings onto the paper. Hold the magnet underneath the paper and move it around. Observe how the iron filings move and align themselves along the magnetic field lines created by the magnet. Explanation: iron filings are tiny particles of iron that can be easily attracted to a magnet due to their magnetic properties. When the magnet is placed underneath the paper, it creates a magnetic field that extends above the paper. The iron filings, being magnetic, align themselves along the magnetic field lines, creating a visual representation of the magnetic field. This experiment can be used to show the strength and direction of a magnetic field, and is often used in science classes to teach about magnetism. Number 2. Magnetic fluid toy DIY experiment. In this DIY experiment, we will create a magnetic fluid toy using simple materials. Materials needed: vegetable oil, water, food coloring. Magnetic particles can be purchased online or extracted from a cassette tape by clear plastic bottle with a tight-fitting cap procedure. 1. Fill the plastic bottle with vegetable oil, leaving some space at the top. 2. Add water to the bottle, leaving some space at the top. 3. Add a few drops of food coloring to the mixture and stir. 4. Add the magnetic particles to the mixture and stir again. 5. Close the bottle tightly and shake it to mix the contents. Explanation: the vegetable oil and water do not mix, creating a layer of oil on top of the water. The magnetic particles are suspended in the mixture and can be moved around by a magnet. When a magnet is brought close to the bottle, the magnetic particles move towards it, creating fascinating patterns and shapes. This experiment demonstrates the concept of magnetic fluid, a fluid that can be influenced by a magnetic field. It also showcases the properties of non-mixing liquids, creating an intriguing and mesmerizing toy. Number 3. Ferrofluid versus Neodymium magnets experiment. In this experiment, we will explore the interaction between ferrofluid and neodymium magnets. Materials needed: ferrofluid can be purchased online. Neodymium magnets can be purchased online. Petri dish or shallow container. Paper towels. Gloves optional procedure. Pour a small amount of ferrofluid into the petri dish or shallow container. Using gloves optional. Carefully place a neodymium magnet near the ferrofluid and observe its behavior. Move the magnet around and observe how the ferrofluid reacts. Use paper towels to clean up any spills or drips. Explanation: ferrofluid is a liquid containing magnetic particles that are suspended in a carrier fluid. When exposed to a magnetic field, the particles align themselves along the magnetic field lines, creating fascinating and intricate shapes. Neodymium magnets are very strong and can generate a powerful magnetic field. When brought near ferrofluid, they create a mesmerizing interaction, causing the fluid to move and change shape. This experiment showcases the properties of magnetic fluids and the power of neodymium magnets. It can be used to teach about the properties of magnets and their interaction with different materials. Number 4. Coin tricks with magnet experiment. In this experiment, we will perform a coin trick using a magnet. Materials needed: a magnet to coin procedure. Place the magnet on a flat surface, such as a table or desk. Place the coin on top of the magnet. Using your fingers, gently tap the edge of the coin to start it spinning. Move your hand close to the coin without touching it and observe how it reacts. Move your hand closer and farther away to control the motion of the coin. Explanation: the magnet creates a magnetic field that affects the motion of the coin. When the coin is placed on the magnet and spun, it creates a small electrical current in the coin. This current, in turn, generates its own magnetic field. The interaction between the two magnetic fields causes the coin to move in response to the movement of your hand. By controlling the distance between your hand and the coin, you can create the illusion of the coin being controlled by your hand. This experiment can be used to demonstrate the properties of magnetism and electricity, as well as the interaction between the two. Number 5. Monster Magnet DIY Slime Magnet Experiment. In this DIY experiment, we will create a monster magnet using slime and a neodymium magnet procedure. In a mixing bowl, mix 1/2 cup of white school glue with 1/2 cup of water. Add a few drops of food coloring optional and stir. In a separate cup, mix 1 teaspoon of borax with 1/2 cup of water until the borax dissolves. Slowly pour the borax solution into the glue mixture while stirring. Stir until the mixture starts to solidify. Then knead it with your hands until it becomes a stretchy slime. Place the neodymium magnet inside the slime and shape the slime around it to create a monster magnet. Explanation: the borax solution is a cross-linking agent that binds the glue molecules together, creating a solid but stretchy slime. By adding the neodymium magnet inside the slime, it becomes a magnetized slime or monster magnet. The magnetization of the slime is temporary and will disappear once the magnet is removed. This experiment demonstrates the properties of magnetism and the unique properties of slime as a material. It can be used to teach about chemical reactions and the properties of polymers. So this was our today's video. I hope you all like this video. Don't forget to hit the like button and subscribe my channel. And also share it with your friends and family. We will be back soon with a new video. Till then, keep supporting and take care.